When environmental shifts occur over decades, it is easy to assume the danger is happening somewhere else. That illusion of safety breaks when those ignored changes manifest as towering wildfires and historic storms right on our doorsteps. The most severe threat to our survival is a pressurized, subterranean creep pushing up from deep within the earth. By the time the damage becomes visible on the surface, the ground beneath our feet is already compromised. This hidden invasion begins at the deltas and estuaries where our rivers meet the sea. As sea levels accelerate, the ocean's heavy saltwater is forced backwards. It slides beneath lighter freshwater, creating a wedge known as saltwater intrusion. This brine moves horizontally through the soil, saturating the water table and turning vital freshwater aquifers into a salt-choked environment. In California's fertile breadbasket, this subterranean salt makes the soil unsustainable for future crops. Farmers find their fields poisoned from below long before they see a single drop of floodwater on the surface. In our coastal cities, this same groundwater seepage introduces corrosive chlorides into the porous concrete and steel of our infrastructure. Once the salt reaches the foundations, it accelerates the erosion of concrete and eats away at steel reinforcement. By the time residents in Miami are wading through seasonal floods, the structural integrity of their buildings has been compromised for years. Whether it is a failing harvest or a crumbling urban foundation, the systems we rely on for survival are often destroyed before the public recognizes the threat. The freshwater defense that keeps the ocean at bay starts in the mountains, but our supply is shrinking. Shorter snow seasons mean the Sierra snowpacks melt too early, leaving our reservoirs empty when they are needed most during the dry months. This inland drying is tied to a massive heat imbalance at the poles, where white ice is rapidly giving way to dark, open water. We are approaching a blue ocean event, a tipping point where the Arctic becomes ice-free during the summer months. Because dark water absorbs solar heat instead of reflecting it, the ocean eventually stays too warm for winter ice to return at all. This heat thaws the surrounding Arctic tundra, which then leaks massive stores of ancient carbon dioxide and methane back into the atmosphere. This transition turns the Arctic from the planet's cooling system into a self-sustaining heater that leaks carbon back into the global loop. That heat is carving massive meltwater rivers through the Greenland ice sheet, dumping enormous volumes of water into the sea. At the opposite pole, the structural collapse of Antarctic ice shelves add catastrophic volume to the rising global tides. Rising water is only half the crisis. Cyclical patterns like El Niño are now acting as a volatile amplifier for atmospheric heat. This map shows how a sea temperature rise of just 2 degrees can push global land temperatures well past the critical 1.5-degree threshold. With ice sheets collapsing and the atmosphere heating, our planetary systems are entering an uncontrollable feedback loop. As planetary temperatures climb, we are beginning to hit the biological limits of the human body. When high heat combines with high humidity, we reach the wet bulb temperature. This is the threshold where sweat can no longer evaporate, making it impossible for the body to cool itself. As these wet bulb events become frequent, entire homelands will be rendered uninhabitable. In drier regions, this prolonged heat extends the wildfire season, starting fires earlier in the spring and pushing them deep into the autumn. These fiery landscapes and uninhabitable zones are the final results of the initial invisible creep. Keeping pace with this crisis requires shifting to massive carbon-negative interventions. The primary mandate is the full elimination of our reliance on fossil fuel infrastructure. We must accelerate the deployment of zero-carbon alternatives, replacing industrial emissions with massive solar arrays and renewable grids. We must also utilize new technologies like carbon-negative cement, which pulls carbon from the air and locks it into our buildings. In our oceans, we can deploy methods like iron fertilization to draw down atmospheric carbon and store it safely in the deep sea. Because the climate crisis destroys us through a slow, invisible creep, our engineering solutions must be global, rapid, and built on a massive scale.